So now that we've talked about other operators in RxJava's Flux class, plus the scheduler class like scheduler's parallelism and so on, let's put all the pieces together and show you a case study or two that illustrates this. We're actually going to have a case study called ex3 that has two parts. And the first part is going to show a whole boatload of Flux operators that we're going to use to create, reduce, multiply, and display big fraction objects asynchronously. So now we're doing asynchronous stuff. And we'll also demonstrate some of those wacky things like on-error resume and on-error stop and so on. This will also show a bunch of mono operators as well, some of which we've shown before, some of which we haven't shown in this context before. And as always, you can find the code here in my GitHub repository in the Flux ex3 folder. We're now in my IntelliJ project for case study ex3. We'll start by taking a look at the ex3 entry point file, which has the main defined. And we're just going to talk about some of the methods here. I think we're going to talk about first three of them in case study ex3 part 1, which are going to do various kinds of exception testing. And then in part 2, we'll talk about the other three. As usual, we register everything with the async task barrier. We run the tasks, which operate asynchronously, and the main thread blocks. Now, as we go through this stuff, it's important to recognize that under the hood, the async task barrier is doing some interesting things that we need to be aware of. And let's go ahead and see an example of this. I'll talk about this code later, but I want you to just note that in the async task barriers run tasks method, there's a call to on error continue. And what that does is it logs the exception and continues processing. We don't want to have an exception cause the async task barrier to stop. And the use of this method, which we need to use here, has some implications for the tasks that are registered with async task barrier, which have to use the on error stop operation in conjunction with the on error resume operator because of the fact we're using on error continue here. So that's just a little bit of a heads up to something that'll be very subtle if we're not careful. Okay, so now let's go over and take a look at the Flux EX, which is where all the fun starts. And you can see here that we have a field that's a random number generator and then a bunch of test methods. As I mentioned, we're going to talk about 3 test methods here that handle exceptions. So this will show off all the subtleties of exception handling with Project Reactor. So here's what we've got. We get ourselves a string buffer because we're going to be doing things in different threads, so we need to make it thread safe. We make ourselves a list of denominators. You can see it's 342015. Note the 0, so the 0 denominator should be a clue that bad things are going to happen. We should then have a local variable. We then have a local variable called log exception and return empty flux. And what that does is it goes ahead and takes whatever exception is passed to it, and it gets the message for that exception, appends it to the string buffer, and it returns an empty flux. So when something goes wrong, we're just going to be like, we're going to swallow this exception, we're going to log it, but we're not going to go any further whenever the exception occurs. So here's what the code looks like. We take our list of denominators, we make that into a flux. We go ahead and make a big fraction, which has a random numerator and a denominator that will be 0 when we get to the item here that's number 4 in this list. So at that point, the 4th item is going to cause an exception, and we're going to use on error resume to log the exception and return an empty flux. So what that'll do is it will have processed the first 3 elements that were non-zero, then the exception occurs, and it should ignore everything else. It returns an empty flux at that point. And we use on error stop to say, really mean it. We really want to stop here. Don't continue any further, please. We will then collect up everything we've got so far, because we swallow the exception, into a list. So we get back, as you can see, a mono to a list of big fractions. And then we're going to use flat map. We're going to use flat map here in a very interesting way. So what flat map is going to do is it's going to process the collected list, and it'll return a mono that's used to synchronize with the async task barrier framework. So this thing is taking in a list of big fractions, and it's returning a mono to void, basically saying we're done. And let's go take a look at sort and print list. This should look familiar to you because we've done this trick before. What we're going to do is we're going to take the list of big fractions, and we're going to quick sort it and we're going to heap sort it, and we're going to do this in parallel because we're using the scheduler's parallel thread pool to run both these computations in background threads. So quicksort and heap sort will run in parallel. We notice how we get back a mono to this. And then what we do is we use the first with signal operator on mono to say, whichever of these asynchronous computations finishes first, be it quicksort or heap sort, go ahead and take the result, cancel the other one. The first with signal works a little differently than completable futures. The other computation is canceled. So you take whichever one finishes first, cancel the other one. And then we go ahead and we display the list. We take the sorted list that comes back from whichever sort algorithm finished first, and we iterate through this, and we go ahead and append it and then display it. And then we return an empty mono to synchronize with the async task barrier framework. Okay, any questions about that? So very, very cool. And that comes back here as the result. I'm going to go ahead and run the program because I want to show you what the result looks like before we get too far along and forget what it did. So as you can see, there's a lot of stuff here. Here is test fraction exception 1. That was the one we just looked at. And remember how I told you that there are 6 elements in our denominator list, but the 4th one was a 0, so that would cause an exception. And indeed, you can see that we get an exception. We log the exception, which was a divide by 0, and then an empty list was returned. So that means that all that were actually handled were the first 3 of the things before we hit the 0 value. So only 3 things get through, and that's exactly what we want to have happen. Okay, let's now take a look at test fraction exception 2. And it does the same thing. It has a list of denominators. Once again, 0 is the 4th one in. And it's going to use log, error, and continue. And so in this particular case, we're going to do from iterable with our denominators list. We get a denominator stream. We go ahead and we take the denominator and use it. Once again, once we hit the 4th one, it's going to throw an exception. Except this time, we're going to use a different error handling operator. We're going to use on error continue. And what on error continue does is it catches and logs the arithmetic exception and then continues processing. So let's see what it's going to do. So log error and continue. You can see what it does is it just logs the exception and things continue on their merry way. All right. Once again, we take the stream we got and we collect it into a list, and then we sort and print the list. So let's go take a look at the results from this because it should be interesting to compare and contrast. So you'll see here, remember for test fraction exception 1, we stopped after the exception was thrown. But with on error continue, we just skip over the one that threw the exception. It's just skipped. We don't, there's no value that's returned whatsoever. And so we process 5 of the elements in the list, all the ones that weren't 0, and those are the results that we get here, which is what we expect. Well, you might get an inkling of where we're headed for the last example here, and it's really kind of fun to show all the different ways to do this. So let's take a look at the last test method. This is test fraction exception 3. And this is going to use on error resume, okay? And it's using on error resume on a mono, not on a flux, but you'll see it, the way it works, it will affect the flux as a side effect, and you'll see what it does. So here's what we got. We've got a string buffer as always. We have a function called error handler, and what error handler does is it logs the exception, which in this case will again be an arithmetic exception because we're going to divide by 0, except what it's going to do this time is it's not going to just quit altogether, which is what the first example did. It's not going to skip over this, which is what the second example did. And instead what it's going to do is it's going to convert the exception to a value, and that value is 0. So in this particular case, when you try to divide by 0, you get a 0. Now, is that the right result? Maybe not, but I'm just trying to show you how these different mechanisms work. So once again, we have a list of integers. We're going to go ahead and use from iterable to have a flux stream of integers. And then we're going to use flat map. So for each denominator, we're going to go ahead and do the processing here. This time we're doing it with the flat map concurrency idiom. So this should look familiar to you. And what we're going to do is we're going to create a big fraction with the denominator, which could be 0. We're going to subscribe to run all the processing in a background thread, or in background threads from the parallel thread pool. And if an arithmetic exception occurs, we're going to catch it and return 0. And then we're going to log the big fractions just so you can see what they came out with. And let's take a quick look at log fraction. You can see it just goes ahead and appends it to the results. Then we perform a multiplication. So after we do all these computations in parallel, the last thread through here is going to call the filter operator. And filter is going to remove any big fractions that are less than or equal to 0. So remember where we converted the arithmetic exception to 0? That will come through as a 0, but then we're going to get rid of it once we get through that for the flat map concurrency idiom portion. So then we go ahead and collect the results into a list and print and sort the results. So let's take a look at what the results are from here. Here's test fraction exception 3. You can see that it does indeed log the fact that an exception occurred, the divide by 0 arithmetic exception. You'll notice that we ended up with 0 times this big constant, which will turn back into 0, of course. And then you'll notice that the final results that come out here ignore 0. So there is no 0 printed because we filtered it out. We got rid of it. Okay, so that is the end of part 1 of the ex3 case study, basically just demonstrating how you can use different forms of exception handling mechanisms with fluxes and monos.